Hi, this is Lee again, and I'm going to show you another subsystem on the TRILLSAT prototype that I've been working on. This is the XMPP or Jabber server that I wrote in Lua in Node MCU on an ESP8266, and it's running right there's the ESP8266, and over here I want to show you I'm running XabberDev 1.0.74, an open source XMPP client, and I'm running it on a Nexus 4 smartphone here. And the craft right now is powered down. It's at night, it's about 1:26 a.m. and there's no USB power, there's no solar power. So I'm going to go ahead and power the thing on to show you what happens. And I'm going to plug in a USB cable which is connecting to some external terminals. These are high current terminals that I extended to the outside of the craft. And when I plug this in, I'm going to show you what happens to the spotlight up here. Okay, it came on, then it went off. And the reason it does that is because by default the craft keeps the light on when it receives power unless the Pi or the ESP turn the light off. This allows a fallback to occur where if those things go down, the ATtiny can get control over the light. And so I'm going to go ahead and show you now what happened. On the Xabber client, it detected ESP bot, the XMPP server, and it says just started. I'm going to go ahead and open that up. Now I can issue commands to the craft. Now that just started as part of the XMPP presence line, and I use that as a status screen. But for the ESP, I don't really use much in the status screen yet, but when the Pi boots up, I use it a lot. So the ESP8266, I've got several XMPP commands, but not a lot. But the Pi, I've got a huge amount, a couple of pages. So I'm going to go ahead and issue a command to show you that the ESP is in control. I'm going to type ESP light on. Okay, the light came on. I'm going to type ESP light off. And the light went off. Now I'm going to do a Pi on command. What that's doing now is it's booting up the Raspberry Pi 0W, and then it's going to go ahead and start the TRILLSAT bot PY program, which actually is the core program for the robot. And so it'll take about a minute to load. Okay, now you see the status screen changed, and it says please set time. So the reason it says set time is because there's no real-time clock on the Pi or the ESP8266, so I set it manually, and then each unit can send it to the other one. But right now, there's the status screen, and if you go over here, it says bat 1%, bat 2%. Those are the first two values. Sometimes the values are not there because when they're not active, they disappear to make more room on the status screen. So right now it says -34. Those are the default states because I haven't read the voltage yet. That 0.5 and the 141.4, that's the roll and the pitch of the craft, the accelerometer. And as you see here, it's about horizontal, so that's what the 0.5 is. However, the roll is horizontal, but the pitch is at, it said 141.4, so if you take 180 and you subtract 141.4, it's about 39 degrees from horizontal. And I can go ahead and move the craft. Here, I'll go ahead and move it, and then I'm going to issue a hi command. Hi just causes a refresh. So I'm going to do that. And it says hello there from TRILLSAT bottom Pi. But if you notice now it says 28.4 because I've just tilted it. I'm going to release it. I'm going to issue high. And 1.4. It's still swinging a little. That M there, that means morning. It doesn't know what zone it's in. It's defaulting to morning right now. When the actual motor turns and the Hall sensors get triggered, it goes into these different, what I call tridents. It's like a quadrant, but there's only 3 of them. And then after that, there's a 2. That 2 is the, let's see, the M was the orbit position 2, solar charge mode. So that means if it were to charge, battery bank 2 would be the one that would charge. The P means parallel. That series are parallel. That means that right now the 2 battery banks are operating in parallel. And that would be, nominal 3.6 volts. And then the M, that would mean those aren't on yet. Those 5.1s and 2s and 7.1s and 2s. The M is the new male indicator. That's part of the packet radio system. Now I'm not going to go into the packet radio system or the motor control system or the power regulation system or the haptic system at this time. Those, I'll put out different videos for that. Those are more complicated. I'm just going to show some basic XMPP commands. Okay, so what else we got here? You've seen high. Okay, Pi Wi-Fi. For example, the Pi 0W has a Wi-Fi card in it, but it's not needed because the ESP, I'm going to go ahead and do a Pi, Pi Wi-Fi off. Pi receive command, Pi Wi-Fi off to turn the Wi-Fi card off. Okay, so now the Pi Wi-Fi card is off, but of course the ESP Wi-Fi card is on, so that will save power because the ESP communicates with the Pi over the UART, so it doesn't need to worry about that. I use the Pi Wi-Fi for SSH console, so I can issue commands through bash, things like that, and then do updates, but otherwise it's not needed. And let's see here, light on off. Okay, CDS, I can issue a CDS command to read the value of the photocells. Now Sawyer is reading the ADCs and it's doing several reads and then it's averaging them, and there we go. So it's reading value of 971 on one and 950 on the other, which is about right because the light is hitting it about evenly. There's one and there's one on the other side, and of course the light's reflecting off of that surface, so they're about even right now. But that's used for solar intensity, to detect where the sun is in the sky and move the solar tracker. It's a separate system from the accelerometer. And let's see, what else do we have? Voltage. I'm not going to show you that yet. That's part of the power system or the solar system. There are the Hall sensors and the gyro. That's part of the motor system. Let's see what else we got. I'm going to go ahead and turn the page. Temperature. So there's several temperature sensors in the craft. I'm going to do a detemp. Detemp did not work. I'm going to do a high just to see if the server's still running. Okay, the server is running. The problem with that's strange. I've been having trouble reading the one-wire interface using the Raspberry Pi through Python. It works through Bash, so what I've done is created a separate Bash script that pulls those sensors and then sends it. Then Python can read it. Let me try it again. I'm not sure exactly what happened. I've tried reading it. Oh, there we go. So it says it reports 76 degrees, 74 degrees, 74 and 76 degrees Fahrenheit. Now there are 4 sensors. One is here on the top, and that detects the heat of the solar panel and the sun directly. Then we've got an external temperature sensor in here in the pulley frame, and that would detect ambient temperature outside. And then there's one inside the gyro unit, and there's one inside the radio box here. Let's see, what else do we have? Pi temp. Okay, it's going to read the temperature of the Pi 0 GPU CPU temp. So let's try that. $122, and that makes sense because it's doing more work. What else do we have? Tiny temp. Read the 2 AT Tiny CPU temp sensors. Huckleberry, that's the power regulation microcontroller, is 74.2. Sawyer, 76.0. Now, a lot of these probes are relative, and I had to calibrate them to the DS18B20s on boot, which are absolute sensors. They're much more accurate. Let's see, what else do we have? LIS temp. There's actually another temperature sensor on the LIS 3DH accelerometer. So let's try that. $74.2. Okay. QI. There is a dock on the craft. It's right here. And there's a QI coil right here that can be turned on to charge the smartphone, this one over here, from solar power that was stored into the battery banks. And that allows the system to be completely independent of the power grid, both client and server. And so I'm going to go ahead and I'll turn that on. You should QI on. Huckleberry received command to turn on the QI wireless charger. So I'm going to go ahead and unplug this. I was just keeping it plugged in because I didn't want it to die on me. And I'm going to go ahead and hold up this Nexus 4 against the dock here. The mass is in the way. Okay, I had to move the mass out of the way to get enough clearance, but I want to show you that those mounts on the side of the QI dock are for rubber bands that can be crossed like that, or a Velcro strap. And if you notice now, the phone is in a charging mode. That's happening because it's using the QI wireless charger. And if I go around back, you can see the light through the translucent plastic. So that means it's on. So if I go ahead and remove it, I'm going to remove the straps. It's now not charging anymore. The reason that's been added is so a coil and a microcontroller like an ESP32 LoRa board and battery can be added at a later date to the planetary mass. Right now it has a ball damper inside, about 1 pound, to change the tilt of the craft. But as you see, the clearance is really close to the QI dock. Right now I need to adjust it a little bit closer clearance. The 1 pound weight is pulling it a little bit too far away. and then I'll be able to use that as an actual dock. So that's what I call the planetary space pod. It spins around, it can dock and recharge, it can be completely independent. There's no electrical connection to the craft itself. It's like a little space pod. Okay, I'm going to go ahead and turn the QI charger off. Okay, it's now off. Now what I'm going to do is show you the radio command. This will turn the UV5RA radio on and off. Now I'm not going to show you the whole packet radio system, but I do want to show you that I can get control over it and turn it on and off. First I'm going to turn on what's called series mode. That P there means the system's in parallel mode, where the battery banks are operating in parallel. But if I type S, you'll hear a little click. That click was a latching relay that put the battery banks in series. So that brings them to a nominal 7.2 volts. It's actually a little more now because of the charge. And now I'm going to go ahead and issue a radio on. But I'm going to hold this up just before I enter it. Now there's the LCD display on the Baofeng radio, and I'm going to go ahead and enter. And there it says TRILLSAT, and there it's showing 145.070. I haven't actually transmitted yet. I don't know if you can see, but the antenna connector is not connected at this point. I don't even have the bulkhead connector in place yet. I've been doing all of my packet radio testing using a simulation, but I have tested the system on the air, the actual the transmitter and interface. I just haven't tested the packet BBS code or the XMPP code that I wrote to communicate with it while it's on the air. So I'm going to go ahead and just turn on the UV5RA radio. Radio off. Radio's off. Put it into parallel mode. Back into parallel mode. Alright, so that's about it just for showing the XMPP communication on TRILLSAT. I'll go over some other subsystems in the future. Thanks.